Hello again, thank you for clicking on the YouTube link to the third lesson on trigonometry, where I am going to take you through how to find an unknown angle in a right angle triangle when we know two of the other side lengths. I hope you find it useful. Here we go. So last time we looked at using trigonometry, that's sine, cos and tan, to find unknown side length. On the screen now you'll see two questions to recap that. If you would like to go at these questions for yourself, then please press pause now. Okay, so the first thing that we do is we write down what we know. So we know that we have an angle of 23 degrees. You've got an opposite side here, opposite the angle of A. Don't know what that is yet, that's what we need to work out. And we've got an adjacent side of 10. So if we go back to our magic word, so, ka, toa, we have got the O and we've got the A. So we are looking at this bit here, which says that tan of the angle is equal to the opposite over the adjacent. We can then substitute our values in. So we can say that tan of 23 is equal to A over 10. Okay, so we can multiply tan 23 by 10 to get A. So A is equal to 10 times tan 23, or 10 tan 23. If we put that into our calculator, so I'm going to double check that I'm in degree mode here, and I'm going to type in 10 times tan 23, and we get an answer of 4.24 to 2 decimal places. Now we've got a second example here. On this example, we have got an angle of 78 degrees. We have got an opposite side of 12 centimetres because it is opposite the angle. And our unknown is the longest side. We know it's the longest because it's opposite the right angle. Our longest side, which is our hypotenuse. So our hypotenuse is equal to B. Okay, I know usually when we see triangles, B would be one of the other two sides in Pythagoras, wouldn't it? But you will often find that on exam papers, in exercises, they do mix the letters around, so just be on your guard for that one. So again, if I write down the magic word, so, ka, toa, we've got the O and we've got the H. So it must be so, or sin of the angle is equal to the opposite over the hypotenuse. So let's substitute in our values. So sin 78 equals 12 divided by our unknown. This causes us a few problems with the unknown being stuck on the bottom here. Let's bring it up to the top by multiplying both sides by B, or our unknown, and we end up with B sin 78, or B sine 78, equals 12. We've still not got our B on its own. We need to divide both sides by sine 78. If I can squeeze that in there. So we end up with B equals 12 divided by sine 78. Put that into our calculator, or my calculator. So 12 divided by sin 78, 12.27 centimetres, and again that's to 2 decimal places. Okay, now we can also use trigonometry to find an angle, and I've got two examples here that I'm going to go through with you. Okay, so we are trying to find the angle when we've got an opposite of 0.8, a hypotenuse of 1 metre, and we've got an unknown angle. Okay, so got the O and we got the H, so it's going to be sine. So sine theta is opposite over hypotenuse, and if we substitute in, we end up with sin x equals 0.8 divided by 1. Okay, so we need to find a value of x such that sine of x is equal to 0.8 divided by 1, which is 0.8. Okay, now here's the graph we did before. Okay, now when we introduced trigonometry, we showed this graph, and for every, if you've got an opposite side for a given angle and a hypotenuse of 1, you went up to the line, traced across. Okay, so for 60 degrees, opposite divided by hypotenuse was about 0.86. We now need to find the angle that gives us a value of 0.8. So we can go up to 0.8, and instead of going to the angle and up, we go to the value of opposite divided by hypotenuse, we trace across, and we read off the angle. So it's like we are doing sin backwards. Okay, so if you had a times, you did a divide, that is times backwards. It's an inverse operation, so we need an inverse sine function. Now hopefully you can see this on my calculator. Above my trigonometric functions, I've got, or you will have on your calculators as well, sin to the minus 1, cos to the minus 1, tan to the minus 1. That's not the same as 1 over sine or 1 over cos or 1 over tan. It's the inverse sin, cos and tan functions. So if you know the value of sin x, you press the inverse sine button like so. So if sin of x is 0.8, x is equal to sine to the minus 1 of 0.8. So I simply type that into my calculator. So when we are finding the angle, we are using the inverse functions. So you can see there it says sin to the minus 1, 0.8, and that gives us 53.13 degrees to 2 decimal places. Okay, let's have a look at another example. So here we have got an unknown angle again. I'll do this in a different colour. So we have got theta is equal to y. We have got the length that is next to it, so we have got the adjacent, which is 2 centimetres, and this is the longest side, which is the hypotenuse. So we've got the A and the H, so it's going to be cos. So cos theta is adjacent over hypotenuse. Okay, Okay, if we substitute in, cos of y is equal to 2 over 8. So cos of y is equal to 1/4, or 0.25. Because we're working out the angle, we're working backwards, we need the inverse function. So we do y equals cos to the minus 1 of 0.25. So if I type that into my calculator, so shift cos gives us cos to the minus 1 of 0.25, and that gives us 75.52 to 2 decimal places. So 75.52 degrees to 2 decimal places. Just give you a second to press pause if you need to, if I've gone too quickly, and then I will put on some more for you to try. Okay, so these are not all finding the angle. Some of them are finding the side, and I've put in a question there to try and catch you out. So if you just want to press pause and have a go at those, and I will go through them one at a time. Okay, so the first example here, we've got an angle that is unknown, that's been labelled x. We've got an opposite of 6 centimetres opposite the angle here, and adjacent of 8 centimetres. So we have got the O and the A, so that's TOA or tan. So we've got that tan of theta is equal to opposite over adjacent. So using our values here, we've got that tan of x is equal to 6 over 8, or 0.75. If we do the inverse tan function, so here, shift tan 0.75, and we get an answer of 36.89. So x is equal to tan to the minus 1 of 0.75, which is 36.87 degrees, and that's correct to 2 decimal places. In the next example here, we have got an unknown angle of x again. We have got an opposite side of 3 centimetres opposite the angle, and a hypotenuse, the longest side, of 5 centimetres. So it's going to be sin, or so. So you end up with sin x equals, I'm sorry, I haven't written down the general rule. Sin of theta is opposite over hypotenuse. So we substitute in sin of x is equal to our opposite, which is 3, divided by our hypotenuse, which is 5. So sin of x is 0.6. So we're working backwards to find the angle. So we end up with x is equal to sin to the minus 1 of 0.6. So shift sin 0.6, and again 36.87 degrees, and that's to 2 decimal places. And I've actually managed, without meaning to, create a pair of similar triangles. 3's doubled to give 6. So on this one, this would have been 10, and this would have been 4. That wasn't deliberate, that. Just had to pause for a second there. In our third example, we go back to finding the side length. So again, we've got the angle of 20. opposite of x adjacent of 4 centimetres. So O and A, TOA or tan of theta is equal to opposite over adjacent. We substitute our numbers in. So tan of 20 is equal to x divided by 4. So to get x on its own, times both sides by 4. 4 tan 20 equals x. So if we do 4 times, or just 4 tan 20, we're finding a side length. So we're using tan rather than inverse tan. So 4 times tan 20, 1.46 to 2 decimal places. Now on example 4, if you're using trigonometry, you would find this quite tricky, because you could find one of the angles using inverse trigonometry and then use trigonometry to find x. However, when we've got a right angle triangle and we are given two sides, we can go back and we can use Pythagoras. You need to be careful you rule out the easier stuff before you embark on trigonometry. So make sure you can't do it through rules of angles, then rule out Pythagoras. Here we can use Pythagoras. So we can use the fact that it's a right angle triangle. So a squared plus b squared equals c squared. Substituting in with c being the hypotenuse. 4 squared plus x squared is equal to 10 squared. We want x to be on its own, so we can do x squared equals 10 squared, take away 4 squared. So we've got to be careful again because we're finding one of the shorter two sides. Okay, so we end up with x squared being equal to 100, take away 16. Okay, so we end up with x squared equals 84. So x is going to be equal to the square root of 84. Okay, now you may be asked to leave your answer as a surd and simplify. That's for another lesson. I'm going to put that into my calculator and assume it's asked for that to 2 decimal places, and I'm going to take the square root of 84, and this will simplify the surd for me if it's possible to simplify. So that's 2 root 21 centimetres, or if you're asked for it as a decimal, 9.17 centimetres, correct to 2 decimal places. Okay, I do hope that you found that useful, and I hope to see you again soon. Stay well, stay safe. Bye bye.